Alright, so this will be part 2 of looking at the 6.1 through 6.3 review. This side wants us to use elimination. So on these elimination ones, some will be a little easier, some will be a little more difficult. Remember, elimination is all about adding the two equations together, trying to get one of the variables to cancel out. Let's start with this first one. It's already ready to go because you might recognize negative 3y and positive 3y will cancel out. Negative x and 2x gives me an x. Negative 3 plus 5 gives me a 2. And there it is. X is solved for. Now, pick one of the original equations. I'm going to pick the second one. 2x plus 3y. Let's leave a spot for our x, though, with some parentheses. 2x plus 3y is equal to 5. Plug in a 2. So we have 4 plus 3y is equal to 5. Subtract the 4 from both sides. Get the 3y is equal to 1. Divide both sides by 3 to get the y is 1/3. Are there fractions allowed? Absolutely. That's we have 2 and 1/3. Alright. So some of them add together very nicely like that. Some of them are going to require some multiplication though. Like check this one out. We've got nothing's going to cancel right away. X and x will become 2x, 2y, negative y will become a y. So I need to pick one of these. Doesn't matter which one. I need to figure out, do I want my x's to cancel or my y's? I'm going to choose for my y's. So if I have 2y, I need this to become a negative 2y, which means I'm going to need to multiply the bottom equation by 2. All right, and I'm going to rewrite it up here on top. That way they're grouped together. So I've got a 2x minus 2y is equal to a, and then 2 times the 6 is a 12. Now I can add these two together to get the 3x, the y's cancel, is equal to a 15. So x is equal to a 5. All right, pick either equation. I'll pick the top one. X plus 2y is equal to 3. Plug in our 5. Subtract 5 from both sides. 2y is equal to negative 2. Get that y is equal to a negative 1. And here is our coordinate point, negative 1, 5. Now remember, just like we saw on the previous page, you can plug in both x and y back into your original equation, and you will be able to verify if your answer is correct or not. All right, and so there's some on this now. On this page, I don't see any here that you're going to have to multiply both equations. Make sure you are comfortable with that. So take a look back at the page that we did yesterday, where we are working with solving systems of equations with elimination, and where there would be somewhere both equations needed to be multiplied by a number. Because all these just kind of cover the medium type on there. But some of the hard ones you could expect to see on the quiz potentially. So make sure you're up to speed on those there. But just keep in mind that you have options on these. So, for example, this one here, you could either choose to cancel out your x's by multiplying the bottom equation by 2. You could choose to cancel out your y's by multiplying your bottom equation by a negative 4 to get this to become a positive 4. All right, let me show us that one. All right, and then we rewrite it up here, where we get a negative 4x plus a 4y is equal to a positive 4. Add these two together, and we get a negative 2x is equal to a negative 2, getting us that our x is equal to a 1. You could have done this the other way and solved for the y. So I could pick either one of these equations, plug x back in. I'm going to pick the second one. X minus y is equal to negative 1. Plug in the 1, subtract the 1, so y is equal to a negative 2, making y a positive 2. And our coordinate point is 1, 2. So the answer key posted on Plus Portals may take different steps than I did here, but all should be reaching the same answer. Let's take a look at this word problem and then leave you guys some time to finish looking at some of these to get some practice on your own. So this is a word problem. A student bought 3 boxes of pencil and 2 boxes of pens for $6. He then bought 2 boxes of pencils and 4 boxes of pens for $8. Find the cost of the box of pencils and pens. So here's what we're going to do. Box of pencils, I'm going to call that X. Box of pens, I'm going to call that Y. So if I bought 3 boxes of pencils, pencils are X. That's 3X. And I bought 2 boxes of pens plus 2Y. And it says for $6. I'm going to set it up equal to 6. So 3 boxes of pencils plus 2 boxes of pens, $6. Next scenario is 2 boxes of pencils, so 2X, plus 4 boxes of pens, so 4Y, is equal to $8. We're going to be able to find the price of both a box of pencils and pens through this problem by the process of systems of equations. I'm going to pick to cancel out my y's because I recognize if I can get this to become a negative 4y, it'll cancel. So with that, I need to multiply everything here by negative 2. Bring it down, so we have a negative 6x minus 4y is equal to a negative 12. And now these are ready to be added up. So we're going to get a negative 4x. Y's cancel out is equal to a negative 4. So a box of pencils is equal to $1. Pick either equation. I'll pick the second one. 2x plus 4y is equal to 8. Plug in the 1. 2 times 1 is 2, so subtract 2 from both sides. 4y is equal to 6. Divide both sides by 4. And we're going to get that y is equal to 3 over 2 if I simplify that. Now we're talking about money, so I'm going to change that 3 over 2 to 1.5. Alright, so it asks, what's the price? Well, a box of pencils is X, so it cost $1. Alright, the box of pens cost $1.50. Alright, that's some of the things systems of equations can do. Help you solve for the price of 2 different items as long as you have 2 equations to help cross-reference. And this is also a little bit of a preview of what we'll be getting into with the rest of Chapter 6, working with some word problems.